The world is largely known through the senses. The sense of sight is one of the most important senses. Through it, we see mountains, rivers, trees, plants, chairs, people, and so many other things around us. We also see clouds, rainbows, and birds flying in the sky. At night, we see the moon and the stars. You are able to see the words and sentences printed on this page. How is seeing made possible? Let's know what makes things visible. Have you ever thought about how we see various objects? You may say that I see the objects, but you, can you see an object in the dark? It means that eyes alone cannot see an object. It is only when light from an object enters our eyes that we see the object. The light may have been emitted by the object or may have been reflected by it. You learned in class 7 that a polished or a shiny surface can act as a mirror. A mirror changes the direction of light that falls on it. Can you tell in which direction the light falling on a surface will be reflected? Let us find out with the laws of reflection. To understand it better, let's perform an activity first. Fix a white sheet of paper on a drawing board or a table. Now take a comb and close all its openings except one in the middle. You can use a strip of brown paper for this purpose. Hold the comb perpendicular to the sheet of paper. Throw light from a torch through the opening of the comb from one side. With slight adjustment of the torch and the comb, you will see a ray of light along the paper on the other side of the comb. Keep the comb and the torch steady. Now place a strip of plain mirror in the path of the light ray. You would observe that after striking the mirror, the ray of light is reflected in another direction. The light ray, which strikes any surface, is called the incident ray. The ray that comes back from the surface after reflection is known as reflected ray. Now, draw lines showing the position of the plane mirror, the incident ray, and the reflected ray on the paper. Remove the mirror and the comb. Draw a line making an angle of 90 degree to the line representing the mirror at the point where the incident ray strikes the mirror. This line is known as the normal to the reflecting surface at that point. The angle between the normal and the incident ray is called the angle of incidence. The angle between the normal and the reflected ray is known as the angle of reflection. Now, measure the angle of incidence and the angle of reflection. Repeat the activity several times by changing the angle of incidence. If the experiment is carried out carefully, it is seen that the angle of incidence is always equal to the angle of reflection. This is one of the laws of reflection. Now, what do you think would happen if I threw the light on the mirror along the normal? Well, if light is incident on the mirror along the normal, then the angle of reflection and the angle of incidence will be the same and they will be equal to 0 degree. Hence, the light ray will retrace its own path. Now, let me tell you one more interesting fact, which is a ray of light is an idealization. In reality, we have a narrow beam of light, which is made up of several rays. For simplicity, we use the term ray for a narrow beam of light. Now, let us perform another activity on reflection. Perform activity 13.1 again. This time, use a sheet of stiff paper or a chart paper. Let the sheet project a little beyond the edge of the table. Now cut the projecting portion of the sheet in the middle. Look at the reflected ray. Make sure that the reflected ray extends to the projected portion of the paper. Bend that part of the projected portion on which the reflected ray falls. Can you still see the reflected ray? Bring the paper back to the original position. Can you see the reflected ray again? What do you infer? When the whole sheet of paper is spread on the table, it represents one plane. The incident ray, the normal at the point of incidence, and the reflected ray are all in this plane. When you bend the paper, you create a different plane from the plane in which the incident ray and the normal lie. Then you do not see the reflected ray. What does it indicate? Well, it indicates that the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. This is another law of reflection. Do you remember which law of reflection did we talk about a while back? Comment below if you do. You know what? To perform the experiment outdoors, if you want, you can use the sun as the source of light too. Also, you can perform these activities by making use of the ray streak apparatus. Now, do you remember that in class 7 you had studied some features of the image of an object formed by a plane mirror? Do you recall those features, like what was the image like it was erect or upside down? Was it of the same size as the object? Did the image appear at the same distance behind the mirror as the object was in front of it? And lastly, could it be obtained on a screen? Let us understand a little more about the formation of an image by a plane mirror in the following way. A source of light O is placed in front of a plane mirror PQ. Two rays OA and OC are incident on it. Can you find out the direction of the reflected rays? Now draw normals to the surface of the mirror PQ at the points A and C. Then draw the reflected rays at the points A and C. How would you draw these rays? Extend the reflected rays AB and CD backwards. Do they meet? If yes, mark this point as I. For a viewer's eye at E, do the reflected rays appear to come from the point I? Since the reflected rays do not actually meet at I but only appear to do so, we can say that a virtual image of the point O is formed at I. As you have learned already in class 7, such an image cannot be obtained on a screen. You may recall that in an image formed by a mirror, the left of the object appears on the right and the right appears on the left. This is known as lateral inversion. I am simply loving this chapter. What about you? If yes, remember to hit the like button. Next is regular and diffused reflection. This time also, let's perform an interesting activity. Imagine that parallel rays are incident on an irregular surface, as shown here. Remember that the laws of reflection are valid at each point on the surface. Use these laws to construct reflected rays at various points. Are they parallel to one another? You will find that these rays are reflected in different directions as shown here. When all the parallel rays reflected from a rough or irregular surface are not parallel, the reflection is known as diffused or irregular reflection. Remember that the diffused reflection is not due to the failure of the laws of reflection. It is caused by the irregularities in the reflecting surface, like that of a cardboard. On the other hand, reflection from a smooth surface, like that of a mirror, is called regular reflection. Images are formed by regular reflection. Interesting, no? Let me ask you something now. Do we see all objects due to reflected light? What do you think? Well, nearly everything you see around is seen due to reflected light. Moon, for example, receives light from the sun and reflects it. That's how we see the moon. The objects which shine in the light of other objects are called illuminated objects. Can you name some other such objects? Comment some of them and let us know. There are other objects which give their own light, such as the sun, fire, flame of a candle, and an electric lamp. Their light falls on our eyes. This is how we see them. The objects which emit their own light are known as luminous objects. You good? I have a question now. Can the reflected rays be further reflected if incident on another mirror? Let us find out. Recall the last time you visited a hairdresser. He or she makes you sit in front of a mirror. After your hairdo is complete, she or he holds a mirror behind you to show how the hair has been done. Do you know how could you see the hair at the back of your head? Well, the reflection of our hair falls on the mirror at the back, which the hairdresser holds, and that reflection gets reflected into the mirror in front of us, which virtual image again gets reflected into our eyes, and we can see the black. We can see the back of our hair. Now, do you recall having constructed a periscope as an activity in class 6? The periscope makes use of two plane mirrors. Now, how does reflection from the two mirrors enable you to see objects which are not visibly direct? Well, the ray from the image reflect in upper mirrors and then reflected ray again reflect in lower mirror, and when we see in lower mirror the reflected rays goes into our eye and we can see object directly. Periscopes are used in submarines, tanks, and also by soldiers in bunkers to see things outside. Now, let's know about multiple images. You are aware that a plane mirror forms only a single image of the object. What happens if two plane mirrors are used in combination? Let us see. Take two plane mirrors. Set them at right angles to each other with their edges touching as shown here. To hinge them, you can use adhesive tape. Now place a coin in between the mirrors. How many images of the coin do you see? Now hinge the mirrors using the adhesive tape at different angles, say 45 degrees, 60 degree, 120 degree, 180 degree, etc. Now place some object in between them. Note down the number of images of the object in each case. Finally, set the two mirrors parallel to each other. Find out how many images of a candle placed between them are formed. This idea of number of images formed by mirrors placed at an angle to one another is used in kaleidoscope to make numerous beautiful patterns. Let's try to make a kaleidoscope. To make a kaleidoscope, get three rectangular mirror strips, each about 15 centimeter long and 4 centimeter wide. Join them together to form a prism. Fix this arrangement of mirrors in a circular cardboard tube or tube of a thick chart paper. Make sure that the tube is slightly longer than the mirror strips. Close one end of the tube by a cardboard disc having a hole in the center through which you can see. To make the disc durable, paste a piece of transparent plastic sheet under the cardboard disc. At the other end, touching the mirrors, fix a circular plain glass plate. Place on this glass plate several colored pieces of glass. It it will be good if these are colored broken pieces of bangles. Now close this end of the tube by a ground glass plate. Allow enough space for the color pieces to move around. Your kaleidoscope is ready. To make your toy attractive, you can wrap the kaleidoscope in a colored paper. When you peep through the hole, you will be able to see a variety of patterns in the tube. An interesting feature of a kaleidoscope is that you will never see the same pattern again. Designers of wallpapers and fabrics and artists often use kaleidoscopes to get ideas for new patterns. What do you think? Is sunlight white or colored? In class 7, you learned that sunlight is referred to as white light. You also learned that it consists of 7 colors. Here is another activity showing that sunlight consists of several colors. Now get a plain mirror of a suitable size. Place it in a bowl as shown here. Fill the bowl with water. Put this arrangement near a window in such a way that direct sunlight falls on the mirror. Adjust the portion of the bowl so that the reflected light from the mirror falls on a wall. If the wall is not white, fix a sheet of white paper on it. Reflected light will be seen to have many colors. How can you explain this? The mirror and water form a prism. As you learnt in class 7, this breaks up the light into its colors. Splitting of light into its colors is known as dispersion of light. Rainbow is a natural phenomena showing dispersion. We all love rainbows, don't we? You know what? I recently saw a double rainbow and it was spectacular. Have you ever seen one? Let us know in the comments below. Next is, what is inside our eyes? We see things only when light coming from them enters our eyes. Eye is one of the most important sense organs. It is therefore important to understand its structure and working. The eye has a roughly spherical shape, as we all know. The outer coat of the eye is white. It is tough so that it can protect the interior of the eye from accidents. Its transparent front part is called cornea. Behind the cornea, we find a dark muscular structure called iris. In the iris, there is a small opening called the pupil. The size of the pupil is controlled by the iris. You might want to draw this diagram of human eye in your notebooks for future reference. Moving on. The iris is that part of the eye which give it its distinctive color. When we say that a person has green eyes, we refer actually to the color of the iris. The iris controls the amount of light entering into the eye. We would see how, but first let's perform an interesting activity. Look into your friend's eye. Observe the size of the pupil. Throw light on her eye with a torch. Observe the pupil now. Now switch off the light and observe her pupil again. Do you notice any change in the size of the pupil? In which case was the pupil larger? And why do you think it was so? In which case do you need to allow more light in the eye? When the light is dim or bright? Of course, when the light is dim, and hence iris increases the size of the pupil so that sufficient light enters into the eye. Behind the pupil of the eye is a lens which is thicker in the center. Now, what kind of lens is thicker at the center? Recall what you learned about lenses in class 7. The lens focuses light on the back of the eye, on a layer called retina. The retina covers several nerve cells. Sensations felt by the nerve cells are then transmitted to the brain through the optic nerve. There are two kinds of cells: cones, which are sensitive to bright light, and
rods which are sensitive to dim light. Cones sense color. At the junction of the optic nerve and the retina, there are no sensory cells, so no vision is possible at that spot. This is called the blind spot. Its existence can be demonstrated like this. Make a round mark and a cross on a sheet of paper with the spot to the right of the cross, as shown here. The distance between two marks may be 6 to 8 centimeter. Hold the sheet of the paper at an arm's length from the eye. Now close your left eye. Look continuously at the cross. Move the sheet slowly towards you, keeping your eye on the cross. What do you find? Does the round mark disappear at some point? Now close your right eye. Look at the round mark now and repeat the activity. Does the cross disappear? The disappearance of cross or the round mark shows that there is a point on the retina which cannot send messages to the brain when light falls on it. Pretty interesting, right? The impression of an image does not vanish immediately from the retina. It persists there for about 1/16th of a second. So, if still images of a moving object are flashed on the eye at a rate faster than 16 per second, then the eye perceives this object as moving. Now get a square piece of cardboard of size 6 to 8 centimeter for our next activity. Make two holes as shown here. Thread a string through the two holes. Draw a cage on one side of the cardboard and a bird on the other side. Twist the string and make the card twirl rapidly. Do you see the bird in the cage? Comment below and tell us. This was fun. Let me tell you another fun fact. The movies that we see are actually a number of separate pictures in proper sequence. They are made to move across the eye usually at the rate of 24 pictures per second, which is obviously faster than 16 per second. So we see a moving picture. Got it? Let's move further. Nature has provided eyes with eyelids to prevent any object from entering the eye. Eyelids also shut out light when not required. Eye is such a wonderful instrument that it can clearly see distant objects as well as objects nearby. The minimum distance at which the eye can see objects distinctively varies with age. The most comfortable distance at which one can read with a normal eye is about 25 centimeter. Some persons can see objects close to them clearly but cannot see distant objects so clearly. On the other hand, some persons cannot see objects nearby clearly but they can see distant objects quite well. With suitable corrective lenses, these defects of the eye can be corrected. Sometimes, particularly in old age, eyesight becomes foggy. It is due to the eye lens becoming cloudy. When it happens, persons are said to have cataract. There is a loss of vision, sometimes extremely severe. It is possible to treat this defect. The opaque lens is removed and a new artificial lens is inserted. Modern technology has made this procedure simpler and safer. Let's see how to take good care of the eyes. It is necessary that you take proper care of your eyes. If there is any problem, you should go to an eye specialist. Have a regular checkup. If advised, use suitable spectacles. Too little or too much light is bad for eyes. Insufficient light causes eye strain and headaches. Too much light, like that of the sun, a powerful lamp, or a laser torch, can injure the retina. Do not look at the sun or a powerful light directly. Never rub your eyes. If particles of dust go into your eyes, wash your eyes with a clean water. If there is no improvement, go to a doctor. Always read at a normal distance for vision. Do not read by bringing the book too close to your eyes or keeping it too far. You learned about balanced diet in class 6. If food is deficient in some components, eyes may also suffer. Lack of vitamin A in foodstuff is responsible for many eye troubles. Most common amongst them is night blindness. One should therefore include in the diet components which have vitamin A. Raw carrots, broccoli, and green vegetables such as spinach and cod liver oil are rich in vitamin A. Eggs, milk, curd, cheese, butter, and fruits such as papaya and mango are also rich in vitamin A. Now, let me tell you an interesting fact. Animals have eyes shaped in different ways. Eyes of a crab are quite small, but they enable the crab to look all around. So the crab can sense even if the enemy approaches from behind. Butterflies have large eyes that seem to be made up of thousands of little eyes. They can see not only in the front and the sides but the back as well. Interesting, isn't it? Next is, do you know that it is possible for visually impaired persons to read and write also? Some persons, including children, can be visually impaired. They have very limited vision to see things. Some persons cannot see at all since birth. Some persons may lose their eyesight because of a disease or an injury. Such persons try to identify things by touching and listening to voices more carefully. They develop their other senses more sharply. However, additional resources can enable them to develop their capabilities further. Non optical and optical aids for visually impaired include visual aids, tactual aids that use the sense of touch, auditory aids that use the sense of hearing, and electronic aids. Visual aids can magnify words, can provide suitable intensity of light and material at proper distances. Tactual aids, including braille, writer slate, and stylus, help the visually challenged persons in taking notes, reading, and writing. Auditory aids include cassettes, tape recorders, talking books, and other such devices. Electronic aids such as talking calculators and computers are also available for performing many computational tasks. Closed circuit television, also an electronic aid, enlarges printed material with suitable contrast and illumination. Nowadays, use of audio CDs and voice boxes with computers are also very helpful for listening and writing the desired text. Optical aids include bifocal lenses, contact lenses, tinted lenses, magnifiers, and telescopic aids. While the lens combinations are used to rectify visual limitations, telescopic aids are available to view chalkboard and class demonstrations. Next is, what is Braille system? The most popular resource for visually challenged persons is Braille. Louis Braille, himself a visually challenged person, developed a system for visually challenged persons and published it in 1821. Braille system has 63 dot patterns or characters. Each character represents a letter, a combination of letters, a common word, or a grammatical sign. Dots are arranged in cells of two vertical rows of three dots each. Patterns of dots to represent some English letters and some common words are shown here. These patterns, when embossed on braille sheets, help visually challenged persons to recognize words by touching. To make them easier to touch, the dots are raised slightly. The present system was adopted in 1932. There is Braille code for common languages, mathematics, and scientific notation. Many Indian languages can be read using the Braille system. Visually impaired people learn the Braille system by beginning with letters then special characters and letter combinations. Methods depend upon recognition by touching. Each character has to be memorized. Braille text can be produced by hand or by machine. Typewriter like devices and printing machines have now been developed. Some visually impaired Indians have great achievements to their credit. Divakar, a child prodigy, has given amazing performances as a singer. Ravindra Jain, born completely visually impaired, obtained his Sangeet Prabhakar degree from Allahabad. He had shown his excellence as a lyricist, singer, and music composer. Lal Advani, himself visually impaired, established an association for special education and rehabilitation of disabled in India. Besides this, he represented India on Braille problems in UNESCO. Helen Keller, an American author and lecturer, is perhaps the most well known and inspiring visually challenged person. She lost her sight when she was only 18 months old. But because of her resolve and courage, she could complete her graduation from a university. She wrote a number of books, including The Story of My Life. That's it, guys. Hope you liked the video. Check out more videos and make learning fun and easy with isaykids. Subscribe now for more.